Hi everybody, this is a video for my 40S Pre-Cal students. This is the last new lesson, and it's not even really a whole lesson, it's just kind of an example for Chapter 5. As we come to the end of Big Bad Chapter 5, where we basically played with graphs, right? Chapter 4 was all about the left side of the screen, where we looked at the unit circle and values around for sine and cos as circular functions, and tangent as circular functions. The inverses of those functions, cosecant, secant, and cotangent. But basically we stuck to circles, whereas here in Chapter 5 it's all about the right side of the screen. It's all about the graphs and the sinusoidals. And we're on our last, basically our last example of an application. And I don't know if you noticed this or not, but these graphs, I could play with this all day. These graphs here, at the end of the day, they look like waves. So it's kind of cool that we're actually going to do an example where we're going to play with waves. So here we are on the page 21 of your booklet. A tsunami is a very fast-moving ocean wave caused by earthquakes that occur underwater. The water will move first down from its normal level. That's important. First moves down, then moves an equal distance above the normal level, then will finally be back up to the normal level. The period of a tsunami is 16 minutes with an amplitude of 8. And the normal depth water at Crescent Beach is 6 meters. For those of you who are unfamiliar with the physics of a tsunami, one of the ways that you can predict, at least for a few minutes, that it's coming is that suddenly the water at the beach actually goes away. It does move down first before the big wave hits. So, what is the maximum and minimum height of the water caused by the tsunami at Crescent Beach? So the maximum would be, of course, the 6 meter normal level plus the amplitude of 8 meters. So that's a 14 meter wave. And the minimum would be the 6 meters minus the 8 meters, which is negative 2 meters. So you're standing on the beach, suddenly the water level drops 2 meters, then suddenly along comes a wave 14 meters high, and head for high ground, or that'll be the end of you. 14 meters is a heck of a tall thing of water to come at you. All right, find a sinusoidal function to represent the tsunami when it first reaches Crescent Beach. Okay, this is how we're going to do this. First of all, we should realize that D is, of course, the normal water level. That's our central axis of 6. A, of course, we can find by subtracting the max and min, so 14 minus negative 2, and divide by 2, which is 16 over 2, which is 8. So the amplitude is 8, and we kind of knew that. It said the amplitude was 8. I didn't really need this formula, but just to show you that it always does work, it did kind of tell me the amplitude was 8. So we found D, we found A. Next, we're going to have to kind of make that decision as to what kind of a graph we want. And since the starting point can be thought of as the normal depth level, so it even sort of says the water will first move down from its normal level. So I think of the normal level as the starting point. And if the normal level is, of course, the D, the trig function where its graph starts at D is, I think I'll make it a sine graph. And if I make it a sine graph, then that's very nice. C is 0 because it starts right on its normal level. So I'll even write that in words here. Starting point at normal level on D at time equals 0. So there we go. So we're starting at 0, 0. But we need to work with the period to find the B value. So period, it actually straight up tells you the period of the tsunami is 16 minutes. So that's my period. And I'm going to have to use that to find B. B is 2 pi divided by period, which is pi by 8. So I'm going to have a pi by 8 in my equation. All right, I think I'm ready to make the equation now. I'm going to use it in function notation. Height as a function of time is. And let's see, that would be, oh, wait a minute. One more thing I have to consider is that the water will first move down. Oh, I'm not on the screen when I do that. The water will first move down. What does that mean for a sine curve? Sine curves normally go up and then down. This one's going to go down because the water decreases, and then it's going to move up. So A is actually going to be a negative, and A is a negative because water moves down first. Okay, so -8 and then sine, and then my B value is pi by 8 times t. I don't have a C value, my C value is 0, so I can just close that bracket. We're good there. And then plus 6. And this is a pretty easy question. All it wants is the equation. Usually there's a part C on here, something where you'd have to either find out how high the water is at the 2-minute mark, in which case you'd plug a 2 in here and do some arithmetic. Or it might be a question like, at what point, or how many minutes do you have before the water's over your head, at say 2 meters, in which case plug in a 2 for the height and then do some algebra to solve it. Or you could solve it graphically. In fact, why don't we try looking at it graphically? Let me see here. I think my window capture here, and nope, capture 3, no, that's the wrong window capture. Window capture 2. I should really name my window captures. Window capture. Okay, I don't. Oh, there's the problem. The problem is, there we go. Oh, that's not the one. See, that is not the one I want. I want window capture 3, which is. Oh yeah, that is the one I want, because I'm just going to go to here. I'm sorry. Getting a little confused here. There we go. I want to go to Desmos. There it is. Desmos. Okay, so we would like to graph, and I'll just type it in first. H of t and equals, and yes, Desmos can figure out function notation, no problem. -8 times the sine of, open a bracket, pi divided by 8. Move your cursor over so that you get out of that denominator, times t. Close my bracket, plus 6. And as you can see, we're going to have to kind of alter my my screen a little bit here. Well, we already know that it goes up as high as 15, so why don't we give ourselves a y. It never goes down to -6. It goes down to -2. So we'll say -3 to say 16 perhaps. There we go. Now we can see a full wave. And let's change the x value. We know that it takes, what is it, 16 minutes. So why don't we go from, say, -32 to +32. That's two groups of 16 minutes. There we go. And now, so there we go. Starting at time 0, the water level 6. It goes all the way down to -2, and then it goes all the way up to 14. So if I wanted to ask you a question like, how long does it take before the water is over your head? Well, let's see. Depends on how tall your head is, right? So why don't I say I think I'm about 180 centimeters or 1.8 meters. So I'm going to graph the line y equals 1.8 meters. And there it is. Look at that. I would be over my head at 1.407 minutes. So I can then time how long, when I notice that the water starts to recede from the beach, let's assume it takes me a few seconds to realize, uh-oh, tsunami's coming, then I have about 1.4 minutes to run as fast as I can and see if I can get away from the wave. Something tells me I'm a goner. Then you could also answer the opposite question. What if you wanted to know how high it would be at a specific time? Like, say, for example, how high is it at the 5-minute mark? Okay, so how high is it at the 5-minute mark? So we'll say, what is h of 5? And it even just tells me what it is. And of course, I can ask it to show me that point if I want. At the 5-minute mark, we're still down here at the water going away. So that's why it's a negative answer. I can also ask for that point, though. If you want to see the point, you just say, please graph me the point 5, comma, h of 5. And it graphs it as a point, and there you have it. There's your point. And you can even label it if you like. There you go. So that's how you can use technology. Of course, you have to be able to do this without technology too. You have to be able to do these kinds of things algebraically. And so there's some questions in the homework that help you do that algebraically. So let's see, let's go back to that window capture. This is what I wanted to do next. Let's go back to this window capture. There. Okay, so what I wanted to do next is I actually wanted to do this question. It's number 1 on the last worksheet in your work booklet. I've already had 3 different people message me about it because it's actually a really complicated question. There's like several little intricacies to this problem. So I thought, you know what, for one last kind of bonus example, I'll do this one. Having said that, if you're watching along at home, feel free to pause the video, go give this problem a try on your own, see if you can get it, then come back and watch me go through it and see if we got the same thing. So pause right now if you want to try the video. How did it go? All right, let's get some paper. And let's see, where should we move this to? Move that in a little bit. There we go. And let's see, let's move, oops, no, that's the wrong window. I don't want to move that window. I want to move this window. Let's move this window around. Okay, so over the period of 1 year with 365 days, the hour of sunrise and sunset are modeled by the equation f of x equals a cos b x minus c plus d. F of x is the time in hours of the day, and x is the day of the year. The following table indicates the hour of sunrise and the hour of sunset for 2 days in Yellowknife. Now, I just kind of cut the problem information. Underneath this, there's an A and B. I think the first thing that confuses people about this is A and B are 2 different questions. There's a different equation for sunrise, and there's a different equation for sunset. So A is the sunrise equation, B is the sunset equation. I had lots of students who thought that they did one equation for June 21st and one equation for December, whatever that is, probably December 21st or 20th, whatever the day is with the shortest amount of sunlight. Solstice, is that what it is? Or no, equinox? I mix those up. Ask an astronomer. Anyway, yeah, so the first thing you have to be able to do in this problem is figure out what the heck the problem wants you to do. So A wants you to do a sunrise equation. So you're using these top 2 numbers, 2 to the 34 and 10 to the 11. Okay, so from here, let's start making an equation for that. So it tells me the period right off the bat. So let's do period first. The period is 365 days, right? And so that means B is equal to 2 pi divided by 365. Then we could say that, all right, so the sunrise is 2:34 a.m. So we're going to have to make an assumption here. We're going to say that time of 0 is going to be like the starting point of the grid in my graph, time 0. And of course, time 0 is equal to actually midnight, or 00, a.m. We're gonna have to switch to military time because we have to deal with the whole AM PM thing. So that means that the earliest that sunrise happens. Could you imagine having the sunrise happen at 2:34 in the morning? I'm glad I don't live that far north. That would mess me up. So the earliest, which would be my minimum, is 2:34 a.m. Now, here's the problem. 2:34 a.m., and this is where I think a lot of people weren't getting the right answer. 2:34 a.m. is not 2.34. It's actually 2 34/60ths. Now the actual question, I looked at the answer key and they went to decimals, the wimps. So I guess I'll use decimals as well. So I'll actually use my calculator and go, what is 2 plus 34/60ths? And look at that, even my calculator doesn't want to go to decimals. I'm sorry, little calculator, but that's what the answer key wants, so that's what we're going to do. So there we go. So that's 2.567. I'll round it to 3 places. So that's 2.567, and that is my minimum. My maximum, the absolute latest that sunrise happens is on the again, the winter day in December, when the day is the shortest possible, and sunrise doesn't happen until 10:11 a.m., which is, it's still a.m., so it's still 10 hours and 11/60ths of a minute. Or, sorry, and 11/60ths of an hour. Sorry, I said that wrong. So that's going to be 10 plus 11/60ths. And so there we go. So again, I want that as a decimal. So that would be a maximum of 10.18, and I just wrote that down wrong. 183 repeating. Okay, so there we have it. There's time, minimum and maximum, and of course now I can use minimum and maximum to find my A and my D values, right? Remember that A is the max minus the min divided by 2, and the D value, move that up. Let me get this, maybe now that we've seen the question we can make this a little smaller. And the D value is the maximum plus the minimum, all divided by 2. So, cursor's in the way, let me get that out of the way a little bit. There. All right, let's see. You know, I don't want to use I've got a calculator that's perfectly capable of working in fractions, so I'm going to ignore the fact that I did write down decimals, and I'm going to work with the fractions so that I have the most accurate answer that I can get. So that's actually 10 and 11/60ths minus 2 and 34/60ths, all divided by 2. And I'm actually just going to use my fraction button. I don't know if you're familiar with using your fraction function. On most calculators, there is a fraction button. It looks like a mixed number. Where is it? It's on here someplace. There it is. It's right there. ABC, like number something over something. Actually, this is a fancier calculator than most people use. Let me use something a little more down to earth here. Let's use this guy. Plus, it actually shows up. This is easier to see with the screen on the desktop here. Okay, so where's the fraction button on this guy? The fraction button on this guy is right here, ABC. And I'm going to enter this as, okay, so watch, I'll enter it over here. Okay, so 10 fraction button. Oh, you know what? Stop, start again. I need a divide, otherwise it won't know to do the subtract before the divide. I need a bracket. So open a bracket, 10 and, where'd you go, fraction button, and 11 over 60. If you've never used your fraction button before, that's what fractions look like when you punch them in on a calculator. Minus 2 and 34 and 60. Close the bracket, divide by 2, and there we go. And again, it gives me a fraction. I want a decimal, so you actually just hit the fraction button and it toggles you to a decimal, and that's the number they have. So 3.8083. I'll round it to 4 places. So that's my, what was that one again? That was my A number. Now let's do my D number. So my D number, using the same button punch sequence. Oops, helps if you start with the bracket that way. Open a bracket, 10 and 11 and 60, plus 2 and 34 and 60. Close my brackets and divide by 2, and there we go, 6 and 3/8. That one actually is not repeating. That's 6.375. Okay, we are rolling. We've got A, we've got D, we've got B. All we need to think about now is C. So let's think about C. What do we know for C? Well, look at the problem. The problem is that we are going to, of course, start with a time of 0, right? So, yeah, let's see. Hang on a sec. Where's the question? Oh, there it is. Okay. I'm sure, you guys can see it, right? Because I didn't actually close the window on the screen. Sorry, still getting used to my technology here. So yeah, so the period is 365 days, so that's the period we're going to need. The C value, though, where are we going to start this thing in our C value? Well, Isn't that is interesting. It's 365 days of the year, and we are going to start it as close as we can to the y-axis. And you're probably thinking, well, this June number right here, June number, that's the closer one than the December number. But you know, it kind of isn't, because think about this. It's a sine curve, right? So it's a curve. It repeats itself over and over and over again. It's cyclical. Rather than going 172 days to the right, why don't I go 10 days to the left? And if you're wondering, 10 days to the left? Yeah, because look over here. 355 days is only 10 days away from the end of the year, which means that'll also be 10 away from the start of the year. So actually, I think for the C number here, what we're going to do is we're going to say C is -10. And that will be my, that'll be how we do this, right? Because C is the day of, or X is the day of the year. And if I started the graph on January the 1st, I would move over 0 places. But I'm going to start on the 355th day of the year, which means I'm going to start 10 places. You know, technically this should probably be 9 places. So you know what? I'm going to assume it's a leap year. How about that? So it's 10 places. So that's the answer that they get. I had, again, 3 different people message me saying, I have no idea how they got their equation. Well, that's how they got all their numbers. So let's put it all together and see what it looks like. So y equals, we're starting at a minimum, right? So that's a cosine graph. Or actually, sorry, no, we're starting at a maximum, right? The latest possible. But it's still a cosine graph, but that means A is positive. So the A value we got was 3.8083 times the cosine. The B value we got was 2 pi over 365. And then it was, and a lot of people told me, I got X minus this number here, 355. Where did they get the plus 10 from? Well, like I said, I'll explain it by showing you a graph in a sec. I got the plus 10 because it's closer to the y-axis, and that's the way they did it too. If you actually remember back to the way I taught this in class, I talk about how when I'm looking at a graph to make an equation, I always kind of want to make the C number as small as possible. I don't know why. It's just easier to look at, I guess. And then finally plus D, which is plus 6.375. So that is their answer. I'm quite sure. You know what? We could go check. Let's see. Let's go to the other window here. Window capture. There we go. And okay, let me go to that window. And actually, I can make this one go away now. There we go. So there's Desmos again. Before maybe we go to Desmos, let me just double check that I do have the right answer. Yeah, I do. 3.808, they only went to 3 decimals, 2 pi over 365. And yeah, they did the same thing that I did, which is something that is kind of the way you do these. You try to think about what the closest C value is to the y-axis, so you can kind of minimize how big your C is. Just to show you, though, that it wouldn't have mattered if you'd have had X minus 355, you are going to get the exact same answer that I got, and I'll show you that. So let's get rid of these guys. We don't need them. Don't need you. And let's change this up. Let's make the x-axis here now go from, let's go from, say, minus 370 to plus 370, right? Because we have to fit in 365 days. And let's see, what's our max and min again? Our max is we go up to, what was the max? The max was 3.8. Oh, no, sorry. No, the max was 10 point something. So I will go as high as, say, 12. And our minimum, we never actually went below 0. So we could just say -1. That'll be plenty of room. There we go. And let's graph our function. So it was y equals 3.8083 cosine, open a bracket, 2 pi divided by 365, get out of the fraction, open another bracket, x plus 10, close bracket, plus 6.375 6.375. Dun, 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 dun. And there is our graph, right? And there you go. So there's our minimum, right, which is the absolute latest, and there's our maximum is right here. But it's also, move over a bit, I guess technically there's no point in going negative. I don't know why I did that. It's not like time can go backwards. So this is January the 1st, and this over here is our maximum at day 355, right? So if you'd have put in the 355, if you'd have had this same equation, let me just copy it and paste it. If you'd have had the same equation, but you'd have plugged in, instead of plus 10, minus 355, dun, 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 it's black, it's red, it's black, it's red. It's the same graph. It wouldn't matter to me which one you picked. Okay, so of course, nobody told me to make it a cosine graph. I could have used the d value, which is here, and I think it's about there, right? Oh, actually, no, the d value is 6.3. Ooh, I'd have to actually figure that out. So let's see, y equals 6.375. There we go. Yeah, so there's the d value right there. And you could have tried to figure out what this point is, but that would have been harder. The question actually gives you the maximum and minimum, right? So that's the way I would do a question like that. I would do it as a cosine because they gave me maximum and minimum. There you have it. That's how I would do that question. Give B a try now that you've seen me do A. And you'll notice that it works pretty much the same. And yeah, so that's this question here. So that's this question here. Let's see, go back. The sunset problem, and then you do an average sunset time. Okay, so there we go. That was that's probably the hardest question on this entire worksheet, and we have it as the first problem, which kind of isn't fair. But now that you've seen me do A, hopefully you can do B. Message me if you have any more problems. Thanks for watching, everybody.